Dear students, in the previous class, we studied about increasing and decreasing functions. But due to some network problem, my video is not broadcast properly. I today continue that topic again. Increasing or decreasing functions. Here, you already studied about increasing and decreasing functions. When the function is increasing, when the function is decreasing. This type of function is increasing, the function is, if it is this type, the function is decreasing. Today, the point, let x0 or x0 be a point. Means here I will tell about the increasing or decreasing of a function at a given point. Let x0 be a given point. X0 point in the domain of definition of real valued function. F. Then F is said to be increasing, decreasing, or constant function, etc. at x0. If the function is increasing or decreasing or constant at x0. If there exists an open interval, there exists an open interval I containing x0, then also the function is increasing or decreasing or strictly increasing or strictly decreasing in I. Interval I on open interval I containing x0 such that F is increasing, decreasing or strictly increasing or strictly decreasing respectively in I. Means let x0 be a point in the domain of the definition of the x0, definition of the real valued function f is said to be increasing, decreasing or strictly increasing, strictly decreasing at x0 if there exists an open interval. I containing x0 such that the f is increasing, decreasing or strictly increasing or strictly decreasing. We shall solve one problem here. Show that the function given by f of x equal to 3x plus 17 is increasing in I. If you know x1 and x2 belongs to R. Let x1 and x2 belongs to R. x1 is less than x2. We already studied about increasing functions. If x1 and x2 x1 is less than x2, then f of x1 is less than f of x2. The function is strictly increasing. If the function x1 is less than x2, f of x1 is less than or equal to f of x2, the function is increasing. If x1 is less than x2, f of x1 is greater than f of x2, or f of x2 is greater than f of x2, then the function is here in decreasing. The function is decreasing. Here the function is increasing. Then I will multiply by 3 both sides. 3x1 is less than 3x2. Then adding 17 both sides. 3x1 plus 17 plus less than or equal to 3x2 plus 17. I multiply 3 both sides and adding 17 both sides. We get here it's the f of x1 is less than f of x2 because it is the function f of x2. If you put x2, you get this one 3x2 plus 17. Here, if you put x1, you get 3x1 plus 17. Therefore, f of x1 and f of x2. F of x1 is less than f of x2. It means the function is increasing. Therefore, the function is increasing. Here, we didn't use the derivative of the function, but we solved this one. This type is lengthy process. But using derivative, we can find the function which is increasing or decreasing in and check the interval also. We check the interval in which the function is increasing, decreasing, or it is constant, etc. Then, therefore, we shall go to the first derivative test. First derivative test. First derivative test for increasing and decreasing functions. Decreasing functions. Here, we already know the function f, let f be a function, let f be continuous on closed interval AB and differentiable in open interval AB, then f is increasing in AB. Here, let f be the continuous FP function which is continuous on closed interval AB and differentiable in open interval AB. Then f is increasing in AB if f dash x is greater than 0 for all x belongs to A. For each x belongs to A. F is increasing in A. If f is decreasing decreasing in closed interval AB if f dash x is less than 0 for all x's belongs to A. Then next, f is said to be constant function, a constant function in closed interval AB if f dash x is equal to 0 for all x belongs to AB. Here, three conditions are there. Here, f dash x is the derivative of the function. Which, if it is greater than 0, the function is increasing. If f dash x or derivative of the function is less than 0, the function is decreasing. Then, if f dash x is or derivative of the function is equal to 0, the function is constant function. The function is said to be constant. Here, the condition is f is continuous function. F is continuous function in closed interval AB and differentiable in open interval AB. You should remember find the derivative of the function. Then note to be here the function is derivative of the function is greater than 0 or less than 0 or equal to 0. Means if it is positive, the value of the f dash x is positive, it is increasing. Negative, if it is negative, the function is decreasing. If it is equal to 0, the function is constant. Proof also there here. By MVT theorem, you can use here MVT theorem. MVT means mean value theorem. You already studied in the previous class in the differentiability, I think. Here we have to prove this one by MVT theorem. The function is given here is the function is continuous in closed interval AB and differentiable in open interval AB. Then there exists by MVT theorem there exists C belongs to AB. Here C means any point in the closed in the open interval AB. Any point C belongs to AB such that f dash C which is equal to B f of B minus f of A divided by B minus A. Here f dash C is equal to, here we taken here is x1 and x2, therefore we have to write f of x2 minus f of x1, then x2 minus x1. x1 and x2 are belongs to open interval A. C is belongs to x2 and x1. Then we take here f dash C into x2 minus x1 RHS side f of x2 minus f of x1. Here f dash C is into x2 minus x1 is equal to f of x2 minus f of x1. Here x2 minus x1 is greater than 0 or positive because x1 is less than x2. Therefore x2 minus x1 is positive. It is positive. The multiplication of this one is depend upon the sign of the f dash C because it is positive. If f dash C is negative, it becomes negative. Or f dash C is positive, it becomes positive. Therefore, value of f dash C is equal to f dash f of x2 minus f of x1. Then sin of f of x2, sin of f of x2 minus f of x1, f of x1 is same that of f dash c. I think you understand this point. If x2 minus x1 is positive, therefore f dash c is depend upon this LHS sign is depend upon f dash c sign. Therefore, f of x2 minus f of x1, the LHS sign of this one is same that of f dash c. Then, if f dash c is greater than 0, then f of x2 minus f of x1 is also greater than 0. Then f of x2 is greater than f of x1. Greater than f of x1. Therefore, this becomes f of, in the LHS side, f dash c is equal to f dash c is greater than 0, which is equal to this one. F dash x also greater than 0. The proof is here. If f dash c is greater than 0, in the RHS side also f of x2 minus f of x1 also greater than 0. Then f dash x is greater than 0, f of x2 is greater than f of x1. It means the derivative of the function is greater than 0, then f of x2 is f of x1 greater than f of x. You already studied in the previous class, the function is increasing and f of x2 is greater than f of x1. F of x2 is greater than f of x1 if x2 is greater than f x1. Here also f dash x also greater than 0, it's equal. Therefore, derivative of the function is greater than 0 at the given point, the function is increasing. In the same way, we can prove other also. Here, the function is strictly increasing. Here, the function is greater than only here. Therefore, the function is strictly increasing function. If f dash c, in the same way, second one, f dash c is less than 0. F dash c is less than 0. That becomes f of x2 minus f of x1 is less than 0. Therefore, f of x2 is less than f of x1. Here also f dash x is less than 0, which is implies f of x2 is greater than 0. That implies here also f of x2 is greater less than f of x1. The function is here strictly decreasing. In the same way, if of x, f dash c is equal to 0, that implies f of x2 minus f of x1 is equal to 0. It becomes f of x2 is equal to f of x1. The function is constant here. The function is constant when f dash c is equal to 0. Derivative of the function at given point is 0. The function is constant. You remember here, if the function is given, you find the points by, I will explain the first derivative test. No, by solving the problems. So that we already one problem solved now. Which one? 3x plus 70. F of x is early class, I solved this problem. We find the f dash x is equal to 3x square. Yeah. First problem I taken here is 3x plus 70. F dash x equal to 3 here. First f dash x 3 is greater than 0. It's greater than 0. Therefore, the function is strictly increasing. Strictly increasing. In the same way, we can find solve the problems. First one, show that the function f given by f of x equal to x cube minus 3x square plus 4 plus 4x x belongs to R is increasing on R Here the function given here is polynomial function. Every function here in this chapter given is polynomial function. The function is x, here x is belongs to R, is increasing on R. Given function is f of x solution. First step is f of x equal to x cube minus 3x square plus 4x. Then find the derivative of the function. F dash x is dy by dx. It's nothing but dy by dx. Differentiate the function with respect to x. Then f dash x equal to 3x square minus 3 into 2x. Therefore, it becomes 6x plus 4. Derivative of x is 4. 4x is 4. Then f dash x equal to 3x square minus 6x plus 4. Then here we can write this one 6x square minus 6x plus 3 plus 1. For taking common 3, I write this one like this. X square minus 2x plus 1 here, which is equal to 3 into x minus 1 whole square plus 1. Here we can understand this is positive because 3 into x minus 1 whole square plus 1 is greater than 0. Because here 3 is positive. 3 is positive. If x is any value of r, if it is positive, square is positive. Whole square is positive. If it is negative, then also it is positive. Therefore, LHS side is positive, which is greater than 0. We can conclude that the function is f dash x is greater than f dash x is greater than 0. Therefore, the function is increasing, strictly increasing. Here, show that the function given by that one is increasing on R. They didn't ask the interval of the function in which the function is increasing or decreasing. Therefore, we can solve by this. F dash x is greater than 0. Check the function. Finding the derivative of the function is greater than 0 or less than 0. If it is less than 0, the function is strictly decreasing, or f dash x equal to 0, the function is constant. I will go to the next problem. Find the intervals. Here, find the intervals in which the function f given by above x equal to x square minus 4x plus 6 a strictly increasing is increasing, b decreasing. Here the question is find the intervals with which the function is, I think you can't see here, find the intervals in which the function f given by f of x equal to x square minus 4x plus 6 is increasing and decreasing, when it is increasing or decreasing. The function is f of x equal to x square minus 4x plus 6. Here first you find the derivative of the function f dash x equal to 2x minus 4. That's why 6 derivative of 6 is 0. Then we equate the f dash x equal to 0. That implies 2x minus 4 is equal to 0. Then taking common 2 minus x minus 2 is equal to 0. Therefore, x minus 2 is equal to 0. X is equal to plus 2. Yeah, x equal to plus 2. Therefore, 2 is belongs to the domain of the function. Then, its the domain is real valued function. It's real number. Like x is equal to 2. It takes the point here on the real number. Here it is minus infinity. It is plus infinity. Here, two intervals are there. Two intervals. Which are the intervals? One is minus infinity to 2. Another is 2 to infinity. 2 to infinity. Real number like this. Minus divided into two disjoint intervals which are minus infinity to 2 and 2 to plus infinity. These are two disjoint sets. Here, in which the function is increasing, we have to find in which the interval, the function is increasing or decreasing. We select some points in between minus infinity to 2. And here also, at this point, f dash x is equal to or greater than 0 or less than 0 or equal to 0, you check. I will write here. Interval and sign of f dash x, f dash x, and nature of function. Nature of function. Here, first interval is minus infinity to 2. Second interval is 2 to infinity. The sign of the function f dash x is here x equal to here it is open interval. Minus infinity to 2 is an open interval. We take some points between these two. Not take minus infinity or 2 plus 2. Between these, if we take 1 or 0 or other minus 2, minus 3, etc. If you take that point, f dash, put the value in the f dash x. F dash x equal to 2x minus 4a. We put the value here. I will take here 1. 2 into 1, 2. equal to minus 2. Sign of the f dash x is negative. It's a minus 2. Therefore, it is negative. The function is decrease. Okay? Decrease. F is decrease. 2 to infinity. In this portion, we take positive value here. All are positive. Here, negative values are there. If you take minus 2, there also minus 2 into 2 minus 4. Minus 4 is minus 4. Minus 8. It becomes minus. All points you taken in the left hand side or interval between minus infinity to 2 or 2 to minus infinity is always negative. Therefore, the f is decreased. But we taken here this positive value 2x minus 4. Here it is greater than 2. It is greater than 2. If you take 2 minus 2, you can't take 2 here. 2.1 or 2.3 etc. Here 1.999 etc. Here 2 into 3 minus 4, it's 6 minus 4 which is equal to 2. It's positive. Therefore, f is increasing. F is increasing. Yeah? To solve this problem, first you find the derivative of the function, then find the x value. Equate the derivative of the function equal to 0, then find the value of x, then find the intervals. Find the intervals. Minus infinity to the real line divides two disjoint sets. Like minus infinity to 2 and 2 to infinity. Then you check the nature of the function, that whether it is increasing or decreasing by like this. We solve another problem. Find the intervals. Find the intervals. Intervals in which the function given by above x equal to x cube 2x cube minus 3x square minus 36x plus 7. One is A, strictly increasing. Second, B is strictly decreasing. Here given here function is f of x equal to 2x cube minus 3x square minus 36x plus 7. First you derive the function f dash x equal to 6x square minus 6x minus 36. We taken common 6x square minus x minus 6. If we equating f dash x equal to 0, it implies 6 into x square minus x minus 6 equal to 0. Here 6, this side is 0. Then x square minus x minus 6 equal to 0. We solving this by splitting x by 5 x square minus 3x plus 12. minus 6 which is equal to 0. Minus 3x plus 2x equal to minus x, and minus 3 into 2 is equal to minus 6 is equal to 0. Then we get x, taking common x minus 3 plus 2, x minus 3 equal to 0. X minus 3 or x minus 2 is equal to 0. X equal to plus 3 and x equal to minus 2. Here 2 points are there. X is equal to 3 and x equal to minus 2. We taking the real number, right? One is minus 2, another point is 3. Here is minus infinity, it's plus infinity. Here, 3 intervals. Which one is? First interval is minus infinity to minus 2. Second is minus 2 to 3. And third one is 3 to infinity. Here, 3 disjoint sets like minus infinity to minus 2 and minus 2 to 3 and 3 to infinity. Here intervals are 3. Then you check the sign of f of x, f dash x, sign of f dash x. Here, sign of checking the sign of x, we put this one, x minus 3 and x minus 2. We take any point between minus infinity to minus 2, it always negative. Less than minus 2 is negative. Which one? Here taken is minus 3, minus 6, minus, all are minus there. Therefore, we taking here minus, put the values in this one. F dash x is equal to x minus 3 into x plus 2. Here we can take minus, it becomes minus. Minus 6 minus 3 is minus. Second is minus greater than less than minus 2 is minus 3. Minus 3 plus 2 is again minus. Here minus into minus. Between minus infinity to minus 2, it becomes minus into minus is equal to plus. Therefore, the nature of the function is here. Nature of the function is increasing, strictly increasing. Second one, minus 2 to 3. Here between minus 2 to 3, we taken here is minus 1, 0, etc. We taken minus 1, here minus 1, it becomes minus. Minus 1, minus 3, minus. Then minus 1, minus 3, here also minus. Therefore, it is minus 2. It becomes minus 1. Minus 1, if we take minus 1, minus 1 minus 3 is equal to minus 4, minus 4. Then here minus 1, it is equal minus 1 here. Minus 1 minus 3, it is minus, it's minus 4. Then minus 1, it is positive. Here taken negative number is only minus 1, then all are positive because 0, next 1, 2, etc. Here minus 1 is, it becomes positive because 2 minus 1 is positive. Therefore, minus and plus, it's equal to minus. The function is decreasing. The function is decreasing. At 3 to infinity, it's 3 to infinity, all positive numbers greater than 3. Therefore, it becomes 4 minus 3. Here, 4 minus 3 taken here is x minus 3 and x minus 2. Apply x is equal. Here we take positive value, any positive value greater than 3, therefore 4 minus 3 or 4 minus 2. Here it is positive, here also positive, therefore positive becomes positive. Therefore the functions increase. Like this, you check the increasing or decreasing function at the interval by solving like this. F dash x is positive or negative, then only we can conclude the nature of the function is increasing or decreasing. Next, I will take one more problem. The discussion. So that the function f of x, which is equal to sin x, is strictly increasing or strictly increasing or strictly decreasing and neither increasing or neither not decreasing. Here neither increasing at 0 to pi by 2 and pi by 2 to pi, and neither increasing nor decreasing at 0 to pi. You already know about the graph of the sin x, or values of 0 to pi by 2. The graph of the function also like this: 0, pi by 2, it's pi. Here by taking graph you can find 0 to pi by 2. 0 to pi by 2, we take pi by 4 is between 0 to pi by 2. 0 to pi by 2, pi by 4 is belongs to 0 to pi by 2. Then sin derivative of sin x, f of x equal to sin x, f dash x equal to cos x, f dash x equal to cos x. We find that value f dash x is pi by 4, f dash x is equal to cos pi by 4, which is equal to 1 by root 2. It's positive, it's greater than 0, therefore the function is increasing. The function is increasing. At pi by 2 to 5, pi by 2 to 5, we take 3 pi by 4. We take 3 pi by 4 is between pi by 2 to 5. Here f dash x equal to cos 3 pi by 4. We taken here is cos of 5 minus pi by 4. It's equal to minus cos pi by 4, which is equal to minus 1 by root. It's negative, which is less than 0. Therefore, the function is decreasing. At 0 to 5, we can't say the function is increasing or decreasing because we go through A and B. Here, A and B. Here, in the 0 to pi by 2, the function is increasing. 5 to pi by 2 to pi, the function is decreasing. Therefore, the function is neither increasing nor decreasing at 0 to 5. We shall continue the next class. Thank you.